So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with upper and lower bounds with a focus on going through some exam style questions. Now before we get started on working with some upper and lower bound problem solving and exam style questions, let's just quickly go through some prior knowledge that you are going to need. So you are going to need to know that a rounded number will have a upper and lower limit, and you also need to know how to find those. And again, there's a previous video that looks at this particular thing that you need to know. The next thing you need to be able to be aware of is place values, so knowing hundreds, tens, units, tenths, hundredths, etc. So what a digit represents in a decimal number or in a large number. Units of measure, so centimeters, millimeters, meters, and weights, kilograms, grams, and etc. You need to have some knowledge of rounding to decimal places and significant figures, and fractions and area. Now, in terms of this, what we're going to do is have a look through some Edexcel questions, which I took off from Maths Genie, so please do not sue me for using this resource. So let's have a look at these questions. So let's just zoom in so we've got a bit of space in terms of this. So this first question says that the weight of a bag of potatoes is 25 kilograms to the nearest kilogram. Now, if you think back to this here, so our nearest kilogram, so what I need to do is take 1 kilogram, I need to divide that by 2. So what I'm going to be doing is plus and minusing 0.5 kilograms to find my lowest value. So the question here is find the smallest possible weight. Well, that's going to be 25 minus 0.5, and that's going to be 24.5 kilograms. For the largest possible weight, I'm going to add 0.5 to 25, so that then becomes 25.5. Well, next question, it says the length of a line is 63 centimeters, correct to the nearest centimeter. So again, I'm going to get 1 centimeter, divide that by 2, so then my limits are going to be 0.5 centimeters. So find the least, which is the smallest. That's going to be 63 minus 0.5, so that's going to be 62.5. And for the greatest, well, that's going to be 63 plus 0.5, that's going to be 63.5. For the next one, it says that a field is in the shape of a rectangle. The length of the field is 340 meters to the nearest meter, and the width is 117 meters to the nearest meter. The question is asking us to find the upper bound of the perimeter. So if I just do a little sketch of a rectangle. Now, in terms of the length, that's 340, and the width, which is 117. Now, for the length of the field of 340 to the nearest meter, well, that's going to be 1 over 2, which is a half. So that's going to be 340 plus or minus 0.5. And then for the width, which is 117 to the nearest meter, that's going to be 1 meter divided by 2, which is 0.5. Let me just get rid of that equal sign because it's not relevant. And let's just put a bubble around here as well. So then that's also going to be 117 plus or minus 0.5. So for the upper, I'm going to use the plus. For the smallest, I'm going to use the minus. Now the question is asking for the upper bound of the perimeter of the field. So what I need to do is to find the upper bound, I need to use the longest length for both the length and the width. So this is going to be 340.5, and I'm going to use 117.5 as a width. So for these numbers, I'm going to do 340.5, 340.5, and 117.5 and 117.5. So in the upper bound of the perimeter is therefore going to be 340.5 plus 117.5 plus 340.5 plus 117.5. Obviously, you could have done 340.5 times 2 plus 117.5 times 2. Whichever floats your boat is entirely up to you. Let's put that into my calculator, and I get an answer of 916, and the units are going to be meters, and there is my final answer. Now, if a question asked me for area, which I'm sure it would, for the upper, I would do 117.5 times 340.5. If it was the least smallest area that I wanted, then that would use the lower bound. So that would be, so if I just get rid of all of this, just to create a bit more space. So the upper, so for the length, the smallest is going to be 339.5 and the upper is going to be 340.5. For the width, it's going to be 116.5 and 117.5. So it's just a case of working with those lengths to find the area if the question did ask me for that. But for this particular question, the answer is. For the next question, it says that the length of a rectangle is 30 centimeters, correct to two significant figures. The width of a rectangle is 18 centimeters, correct to two significant figures. Now, again, with this question, if I look at 30 centimeters, 3 is my first sig fig, and the 0 is my second sig fig. So the first sig fig represents tens, and the second sig fig represents units. So what this question here is saying, that for the upper bound, this has been rounded to. So where it says correct to two sig figs, this has been rounded to the nearest unit, because that's what the second sig fig represents. For 18, that's going to represent the exact same. So the second sig fig is the second number that represents units. So that's also been rounded to the nearest unit. So in terms of the upper bound of the width, so here I look at the unit and I divide that by 2. So it's going to be 18 plus or minus. So let me just get rid of all of this for now. So in terms of the width, then that's going to be 18 plus or minus 0.5, so that's going to be 17.5 and 18.5, and this question asked me for the upper bound, so the answer is going to be 18.5. Now for question B, the question says to calculate the upper bound of the area of the rectangle. So again, for this, what I'm going to do is I'm going to do a little sketch of my rectangle, and I want the upper bound of the area. So what I'm wanting is the longest possible length and the longest possible width. So the longest possible length is going to be 30.5 and the longest width is going to be 18.5. So working for the maximum area, so the max area is therefore going to be 30.5 multiplied by 18.5, and again using my calculator to do this, 30.5 times 18.5 gives me an answer of 564.25. And although the units are a bit wrong there, it should be centimetre squared. So now let's look on a very similar question. So this question here is giving me a rectangle again. It says not drawn accurately, obviously. So it says the length of the rectangle is 35 centimetres to the nearest centimetre, and the width is 26 to the nearest centimetre. And again, it's asking me for the upper bound of the area. So for this, to find the limits, I just need to plus or minus half a centimetre. So in terms of so the width is going to be 25.5 or 26.5, and the length, the two limits are going to be 34.5 or 35.5. This is the minimum, this is the max. So to find the upper bound of the area, I need to use the two maximum values. So here the maximum area is going to be 26.5 multiplied by 35.5, and it is really important that you do show you're working out for this question. So 26.5 times 35.5, and that gives me an answer of 940.75, and it's going to be centimetre, not cubed, squared. Done. And that question was worth 3 marks. So obviously I'll write the answer here, so 940.25. I'm not going to get any marks for the unit, so where would I get the marks? Well, I'd get the marks for using 26.5, 35.5, and 1 mark for the correct digit. But you need to make sure that you are showing the upper values, lengths, and the upper value for the width as well in your working. Now moving on to question 6, again we've got another rectangle. So it says the field is in the shape of a rectangle, the width of the field is 28 meters, measured to the nearest meter, and we want to work out the upper bound of this. So again, measure to the nearest meter, which is 1, so we do divide that by 2, we get 0.5. So then for the upper bound we're going to do 28 plus 0.5, which is 28.5. The next question then says that the length of the field is 145 measured to the nearest 5 meters. So here I'm going to do 5 divided by 2, which is 2.5. And the question is asking what's the upper bound of the perimeter. Well, the upper length is going to be 145 plus 2.5, which is 147.5. And to work out the perimeter, I need two lengths and 2 widths. So the perimeter in terms of the max is going to be the upper bound of the width, which is 28.5, plus the upper bound of the length, which is 147.5, and I need 2 lots of that. So let's just either add another lot or times it by 2. And on my calculator, if I then work that out, so I've got 28.5 plus 147.5, which gives me 352. So looking at question 7, it says that Steve measured the length and width of another rectangle. He measured the length to be 645 millimeters to the nearest 5 millimeters, and the width is 400 to the nearest 5 millimeters. And the question is asking, calculate the lower bound of the area of this rectangle. So again, to work out the area, I do length times the width. So what I need is to find the lower bound. So I want the lowest of the lengths and the lowest of the width. So the length is going to be, well, nearest 5, that's 5 divided by 2, which is 2.5, and again 5 divided by 2, which is 2.5. So for the length it's going to be 645 plus or minus 2.5, and for the width it's going to be 400 plus or minus 2.5. So in terms of the lower, which is what I'm wanting, I want the lowest length, which is where we take away, and I want the lowest width, which is again where we take away. So then the lower area is going to be 647.5. No, it's not. It's going to be 600 and it's going to be 642.5 multiplied by 397.5. And if I type that into my calculator, so I've got 642.5 multiplied by 397.5, I get an answer of 255,393.75. But because the question has asked me to round it to 3 sig fig, my third significant represents 1,000, so I want to round this number up to nearest 1,000, which gives me 25500, and again circling that, less than 4 turns all the other numbers turn into zeros, and so we get our answer of 255,000. So moving on to question 8, which thankfully does not involve a rectangle. Let's have a look at how we do this particular question. So reading the questions carefully, we can see that the average fuel consumption C of a car in kilometers per unit, litre, is given by the following formula. And we've got C equals D over F. Now D is 163 correct to 3 significant figures, and F is 45.3 correct to 3 significant figures. And the question is asking us, by considering bounds, work out the value of C to a suitable degree of accuracy. You must show all of your working and give reason for your final answer. So for this, let's have a look at what we should have. Now there's no indication in this particular question to tell me that I'm wanting the upper or lower bound, but what I need to do is actually find that lower and upper bound of C. So first things first, let's have a look at the limits of D. Now D is given to 3 significant figures, where our third significant figure represents a unit, so that's going to represent 1, and if I halve that, it gives me 0.5. So the limits of D is going to be 163 plus minus 0.5, which that gives me a lower limit of 162.5 and an upper limit of 163.5. If I then look at the limits of f, which again is given to 3 sig fig, so that's going to be our third significant figure is 0.1, divide that by 2 and that gives me 0.05. So to find the limits of f, I'm going to do 45.3 plus or minus 0.05, which then would give me an upper and lower bound of 45.25 and 45.35. Now, using these values and knowing that I've got my fraction, so working with c, so to work out the limits of c, now to get the smallest fraction or the lowest of c, what I need the smallest d value over the biggest f value. And for the upper value of c, I need the biggest value of d over the small value of f. So what I'm then going to do is use these numbers here. So here, in terms of the lower limit of c, it's going to be the smallest d value, which is 162.5, over the biggest value of f, which is 45.35. And if I enter that on my calculator, I'm going to do so now. So 162.5 divided by 45.35, it gives me an answer of 3.58324145. Now the upper value of c, so upper c, is going to be where I'm using the biggest d value, which is 163.5, over the smallest of f, which is 45.25. And again, if I type that into my calculator, I get an answer of 3.613259669. So these are where the values of c is going to lie. Now the question has asked me not to give the upper or lower bounds or one or the other. It's actually asked me to work out the answer to a suitable degree of accuracy. Now with these two numbers, what I then need to do is I need to see to how many decimal places will the answer actually change. So to 0 decimal places, both answers would give me 4. But again, that's not very accurate in terms of these decimal numbers. So let's have a look at to 1 decimal place. Well, to 1 decimal place, so let me just write, so to 0 decimal places, both answers give me an answer of 4. So just write both give me an answer of 4. To 1 decimal place, it's going to be, the top number is going to be 3.6, the bottom number is going to be 3.6. To 2 decimal places, the top number would be 3.58 and the bottom number would be 3.61. So it's to 2 decimal places will I get actually 2 different answers. So to this, what I then need to do is give my answer to 3.6 to 1 decimal place, and the reason for that is because both limits give the same answer, and that will be your answer for question 8. Now moving on to question 9. So again here we've got a formula for voltage, which is V equals IR, and it says that given that V equals 218 to correct 3 sig fig and R is given to 12.6 correct 3 sig fig, we want to work out the lower bound of I. Now for this, what we need to, we've got our formula in terms of V. So here we've got V equals IR. So what we need to do is get I the subject. We do that by taking the R over to the other side. So I've got I equals V over R. There is my formula. Now again, we've got a fraction very similar to before. Now if we want the lowest possible I, so the lowest or the lower bound of I, that's going to mean that I want the smallest number at the top and the biggest number at the bottom. So looking at my limits of V, so to 1 sig fig, V is going to be rounded to nearest unit, which is what the third significant figure is. So it's going to be 218. So that's going to be 1 divided by 2, which is 0.5. So that's going to be plus or minus 0.5. Now with R, the third sig fig is a tenth. So that's going to be 0.1. So I'm going to divide that by 2, which equals 0.05. So for r, the limits are going to be 12.6 plus or minus 0.05. Now to get the lowest I value, the smallest I want the smallest v value, which is going to be 217.5, divided by the biggest r value, which is going to be 12.65. Now if I then work that out into my calculator, which I'm going to do right now, so 217.5 divided by 12.65, it gives me an answer of 17.19367589, and I want to round that number up. So the question is, what do I actually round this number up to? Well, I'm going to do it to 3 sig fig because that's what it's given me to. So the final answer is going to be 17.2. And does it say what the units are? Yes, it's going to be, there is my final answer. And again, it's worth just writing down that I have rounded this up to 3 sig fig. So let's have a look at our last example. So looking at here, so it says that m equals the square root of s over t, and s is given 3.47 to correct to 2 decimal places, and t is 8.132 correct to 3 decimal places. By considering bounds, work out the value of m to a suitable degree of accuracy. You must show all you're working out for and give your reason for your final answer. So for the smallest m, so let's work out the limits first. So for s, it's been corrected to the nearest 2 decimal places, so that's going to be 0.01, and I'm going to divide that by 2, which gives me 0.005. Now for t to 3 decimal places, well, that's 0.001, so if I divide that by 2, I'm going to get 0.0005. Now these numbers are going to be important. So for s, the numbers are going to be 3.4, should I say, 0.7 plus or minus 0.05. And for t, it's going to be 8.132 plus or minus 0.0005. Now, in terms of this, we want to work out the lowest m. So the lowest m is again where I'm going to have the smallest at the top and the biggest at the bottom. So for here, I want the smallest s value, which is going to be 3.465 square rooted all over the biggest t value, which is going to be 8.1325. Now if I type that into my calculator, which is not the easiest to type in, so do always make sure you are doing it correctly, divided by 8.1325, it gives me an answer of 0.22889033839. Now for the biggest m, I want the biggest number at the top and the smallest at the bottom. So entering that in, the biggest s value I can have is going to be 3.475, and that's square rooted, over the smallest t value, which is going to be 8.132, take away 0.0005, which is 8.131 and 5. So from this, what we can then do is work this out. Now by working this out, I get an answer of 0.229248623. Now again, when it comes to we need to write to a suitable degree of accuracy. We want to look at rounding where these two numbers here will give me the same number. So here, as I've mentioned, we've got 2 decimal places, 3 decimal places, we've got a mixture. So for this, I would say that if we round our numbers up to 3 decimal places, you can see here that it would give me the same answer, because this rounded up would give me 0.229, and this number rounded up would also give me 0.229, which seems very reasonable. So for this, I would say my final answer is going to be 0.229 to 3 significant figures, as both round to this value. And when we mean by both, we mean our upper and lower bound. Now a question could be, could I round this up to 2 decimal places? Well, yes, you could have, because both would have given you 0.23 as your final answer, and that would have been absolutely fine. I definitely wouldn't have gone 1 dp, because again, looking at the accuracy of these particular questions, you're going to want some level of accuracy, and just 1 decimal place just isn't going to be accurate enough. And let's have a look at this other popular question. And this question says that a carrot weighs 40 grams to the nearest gram. What is a maximum weight of 20 carrots? So for this, what we need to do is first find out the upper and lower limits of the carrot. So here I'm going to do to the nearest gram. So that's going to be 1 over 2. So that's going to be 0.5. So it's going to be 40 plus or minus 0.5. So the lower limit is going to be 39.5. And the upper is going to be 40.5. Now, in order to get the maximum weight, so for the max weight, we need to then multiply 20 by the upper weight. So the maximum weight is going to be 20 times 40.5. And if I reach for my calculator to do just that calculation, I get 810. So looking at our last example, it says that a sweet weighs 15.6 grams to 1 decimal place. What is the maximum number of sweets in a 3 kilogram bag? So first things first, let's work out what the upper and lower bound of the sweet is going to be. So to 1 dp, that's 0.1 divided by 2, which is 0.05. So all I'm then going to do is do 15.6 plus or minus 0.05, which then gives me 15.55 and 15.65. Now, to get the maximum number of sweets, I want the sweet to weigh as less as possible, because obviously the lighter the sweet, the more you're going to fit in a 3 kilogram bag. So to the maximum number of sweets, is going to be the lowest weight of the sweet, and then we're going to divide that from 3,000 grams. So here the calculation we're going to do is going to be 3,000 divided by 15.55. And if I do that calculation on my calculator, so 3,000 divided by 15.5, I'll get an answer of 193.5483871. And obviously we want to look at whole sweets, so it's going to be 193 sweets. And there we go.